Good morning, guys. Alright, so welcome back to my channel. As we talked before, we were going to go through the CCNA certification path, and one of the best ways to start this training is by actually doing a plan, a study plan. So we have an idea of what to study, where to focus very strongly, and also do a schedule. Put a date on the calendar to study the theoretical part as well as doing the practices, which are very important to be able to really master all the subjects that come in the certification. So we here can see the cisco.com website directly on the CCNA certification and training section. And as you can see here, it tells us it's just one exam. It can be taken online, just with a webcam and a computer at home. And it is actually the first step for the Cisco networking path. If we scroll down a little on the website, we will see download at a glance, which gives us a broad idea of how the certification is composed, and the infographic. There are study groups as well. There's a community where you can see previous questions that other people have asked. For example, if there are any vouchers to take advantage of, sometimes they publish that. If they recommend any specific study materials for certain topics. There are also videos on the website as well, related to specific topics from the for the certification. Personally, I read some of them. I heard some videos too, related to the most specific configurations on the CLIs. They were very useful. In general, for all the basic topics, understanding of protocols, and the functioning of the devices and the communications, I took other trainings, which I will also show. Training that I really strongly recommend, pretty complete trainings. So here I downloaded the exam plan. This is the blueprint, where it tells us the exam description, version 1. It could change. Alright, by the time I downloaded this one, it was today, Monday the 13th. Alright, it could change. So you make sure you download the most recent one to have the most up-to-date information and accurate information. Here, as we can see, it gives us the percentages, and the higher the percentage, the higher the effort we will do when studying for it. Here, as you can see, 25%, sorry, let's go back there. 25% is IP connectivity, all right? Routing protocols, next hop, network mask, administrative distance, default route, network route, floating static, OSPF version 2, Ipv4, router ID, the network mask, the prefix, IP addressing. That's why we need to be very sharp on our calculations. We need to be able to detect the network portion as well as the host portion based on the CIDR mask. And we need to know the classes by default, the private addresses, public addresses, there will be questions like that. They will ask you, what is this, a private address or a public address? Is this host part of this network, or is that other, it's part of a different network? How many hops are in a specific segment where two routers are connecting and a network? Many questions like that. They will also ask you to convert from the decimal version to the CIDR version, classless, subnetting. They will ask you how many bits do you have to borrow from the host portion in order to have a specific number of hosts and specific number of networks. So we have to be very sharp. There's a limit, a time limit on the test. So we have to be able to solve those questions very quickly. Whenever I took the test, I remember I took probably 1 minute to calculate most of those subnetting related questions, and that gave me actually more time to work on the heavier questions that actually require more minutes. All right, now next topic with a high percentage, network fundamentals. Routers, the roles of the network components. What do switches do? What do routers do? Alright, there are layer 2 and layer 3 switches. Tell the difference. Layer 2 only forwards frames. Layer 3 can work with frames, but also can do inter-VLAN routing, which means they do understand IP addressing. Next generation firewalls and IPS prevention system, intrusion prevention system, that's what it means. So how does it work? How does it block certain traffic from coming into a network? How does it allow specific traffic? How can you, it's just explanation. All right, here we have to read the verb. This is really important. Explain the role, because some things you just need to know the concepts, and you will expect that in general in the test. All right, most of the times whenever it says explain, they will just bring you multiple possible answers for a specific question, and they are conceptual topics. Very rarely you will find questions where they actually ask you to configure something, what type of actions you would take in a command line interface or a user graphic interface to configure a certain functionality. Very rarely. That's why they say explain. Here it just says explain, so you need to know the concepts and expect those type of questions. Then access points, those are for Wi-Fi, controllers, Cisco DNA Center, which is the central control for management in a software defined networking environment. Endpoints, basically any computer that wants to communicate in the network, including smartphones, printers, alright, all of those host devices, endpoints, servers, and the characteristics of topologies. You need to know the bus topology, star topology, mesh topology, combined or hybrid topologies, 2-tier, 3-tier spine leaf. That talks about the campus network, traditional campus architectures where you have 2 layers or 3 layers. Wide area network, how is the internal network connecting to the internet, for example, to the WAN, wide area network. You need to know NAT, network address translation, port address translation. And here it says describe, so you will find a deeper understanding type of questions for that one. All right. On premises and cloud, what's the difference between having some servers in an office, on site, and the security related to it? How is it different from a cloud environment? What are the advantages and disadvantages in terms of security and setting it up, functionality, speed, service availability? All of those things you need to know. Small office, home office. What's that type of device? It's actually a compressed device. It's a device that has, most of the times, all the layer 2 and layer 3 capabilities, as well as firewall capabilities in one small device. That's used for small offices or home offices, as it says, and also sometimes in small enterprise startups. So compare physical interface and cabling types. Very basic subjects, all of this. You need to know the RJ45, twisted pair cabling, shielded twisted pair cabling. How would you patch a cable to? You could find questions like that. There are two standards, A and B, that you need to know the color coding. If you will put brown and red at the bottom, and then green, and then at the top blue, which means the specific order of the cables, how you will build them. You need to know the straight through cable, the crossover cable, how it allows communications between nodes or devices. There are some devices where normally, if it's the same device connecting to the same type of device, for example, a computer to a computer or a computer to a router, which is more or less like a computer, technically, you would need to use a crossover cable. And for different type of devices, for example, a computer connecting to a switch or to a hub, then they need to use a straight through cable. You also need to know the new technologies, MDIX, which automatically, even if you use a different type of cable than the one you're supposed to use, nowadays the technology allows to automatically correct it. But you do need to know those basic subjects. You need to also know single mode fiber, multi-mode fiber, copper. You need to know the distances and the differences between the cables functionality. For example, the straight through cable, the coaxial cable, has a certain distance limit, as well as the twisted pair cable, 100 meters maximum. Single mode could be up to some kilometers, depending on the type of cable, 40 kilometers. And how the information travels through the cables, that's also an important subject. In the copper cabling, you have some electrical pulses that travel through the copper wires. There are some receiving and sending wires too. You need to know how many sending wires you have in a twisted pair cable. For example, in a Ethernet cable, you have 8 positions for connectors. So that means a pair sends and a pair receives. And then you have to know the sequence. For example, 1, 2, 3, then 2 to 6, for example. You need to know the combinations. And then in terms of fiber, you need to know single mode and multi-mode. You need to know that single mode cable works with a LED, an LED light, which bounces on the walls of the internal transmission path. in the form of light, it has a specific limit in terms of distance, and also you need to know single mode fiber, all right, where the light traverses in a straight line pretty much, and instead of using an LED, it uses a laser beam, which allows it to travel further distances than multi-mode fiber. Then there are some color coding for the cables as well, especially for the fiber cables. There's a external color coding, which does matter. When for copper cable, that's irrelevant. That's just used for human recognition. Like visually, you can tell, you can have a certain order on the structured cable that you set up. Now, concepts of power over Ethernet, that's also important to compare. Here it says compare. We need to really focus on the verb. That helps us a lot because we know how deep to study. Here, for example, concepts of PoE, I actually studied pretty deeply because I also learned how to actually run some commands in the routers and the switches in order to find out the speed, the amount of voltage for the devices that are connecting, power over Ethernet. There's another way also to tweak those settings. You can specify the amount of voltage that is considered to be allowed for an interface to send power to a device. But here it says compare, so really what we should be expecting is just concepts. All right, conceptual type of questions about PoE. How does it work? What does it help us to do? For example, in practice, sometimes it's very useful for us to be able to restart a device, because if we shut an interface on the physical layer and the protocol layer, if we go to the CLI and we say shut down to an interface, and that interface is actually connecting to a power over Ethernet device such as a camera, phone, etc. Whenever we do a not shut down command, whenever we pretty much turn the interface back on, it will regain power, basically resetting the device. Sometimes those devices are they have the need to be restarted for X or Y reason, and that's a good way of doing it. So power over Ethernet, it's very useful. It also saves us space because we avoid using a power injector. Otherwise, we need a power injector. Identify interface and cable issues. So collisions, half duplex. You need to know the difference between that and full duplex. CSMACD, that's the protocol that waits to listen to the cable to see if there's any collisions, and then it waits for a random amount of time to send the signals. Only one signal can be sent at a time. Full duplex allows for complete throughput, simultaneous throughput. Information can be sent from one device to another simultaneously, avoiding collisions. That also talks about, on the network side, we have some areas known as collision domains, as well as broadcast domains. So we need to know how the collision domain is whenever we're using a hub type of device, all that network, local area network that we're talking about, is actually a collision domain. And whenever we're using a switch, it actually creates multiple collision domains, of one for each interface pretty much. And that helps a lot in terms of the efficiency of the network. Then errors, you also need to know, in order to identify, as it says here, you need to know some commands. I would recommend you go through this Cisco documentation about how to find you can do a show interface status command, and it will give you CRC errors, it will tell you runs, it will tell you giants, so you can get an idea of if there's a also mismatch in the duplex. You also need to know how to configure. I would recommend you to know, and that's a pretty simple task. Go to the interface configuration level, so you do enable to go to privileged mode, then config T to go to configuration mode, and then type in the interface number, int gig 00 or fast 00, 01, 02, etc., and then set up the speed and duplex for those interfaces for them to match. You can put them in auto mode, and then the other side, the other interface should also be in auto mode or to the maximum speed that it can run. You also need to know the basic rules for the automatic setup. For example, if there's if the devices are incapable of doing a negotiation, the interface will try to identify it, will try to sense the speed on the other side and will set the speed accordingly. But if it's less than 10 megabits per second, then it will actually set the interface in duplex mode. So you need to know those rules, basic rules of how it works. And if you manually set up the speed and the duplex, then they have to match. Otherwise, the protocol will go down. So that's cable issues. Also, in the hardware part, you need to know why there's a twist in the cables. There's a reason, and that's to avoid electromagnetic interference. Now compare TCP and UDP. Those are protocols from the transport layer, and what they do is transfer control protocol and user diagram protocol. They put a mark on the packet. We will have a port number assigned in that layer, in the transport layer, and additionally, if it's TCP, it will do a three-way handshake. That means the packet must arrive to the destination. We want to make sure it arrives. And once it arrives to the destination, we get an acknowledgement for it. So we send initially a synchronization bit, then we get an acknowledgement and a synchronization bit from the other side, and then we send an acknowledgement. That's the three-way handshake, and it works based on some random sequences that are selected. The initial synchronization number has a random number, normally between 1 to 100, and then the acknowledgement will be +1. So the other device will acknowledge by adding 1 to it. But then it will also generate its own synchronization number on its own, which will be received on our side, and we also need to add a number 1. Well, the computer does it, of course, and then we have the acknowledgement bit, which is whenever we completely recognize, yes, the packet has arrived successfully. That makes the packets bigger, the segments bigger and heavier to use on the network. And the UDP actually avoids doing any of that. It just sends the information, and if it reaches the destination, good. Otherwise, it just continues sending the next packet. While TCP, if a packet is lost and the acknowledgement is missing, it will resend the packets until they reach the destination. So that data, regular data like photos, text, videos, all of those type of things normally utilize the TCP protocol, while voice and video conferencing normally use UDP. It's called real-time traffic, and that becomes relevant too later on for quality of service, because we need to know the functioning of these protocols in order to specify specific rules that will help us improve the network functionality. For example, in terms of TCP, if it's a TCP type of protocol, type of application that's on the network, and it's about to use a lot of, just imagining, a lot of bandwidth from the bandwidth available, we can set up a minimum and a maximum threshold. And whenever that amount of data reaches the threshold, we can set up policing or shaping. And for TCP, we can actually use policing, which drops some packets intentionally in order to avoid congestion. That's congestion avoidance. And UDP, normally, because of its nature, where it lacks the option for the three-way handshake, it just sends the data. The packets are actually smaller, the segments are smaller, so we can give them a privileged type of treatment, and we can specify the rules for them to have reserved. We can say not the RSVP protocol, but normally DF integrated differentiated services type of QoS, and we can give it a prioritized treatment, assigning some bandwidth, minimum bandwidth and maximum bandwidth, to prioritize that type of traffic, voice traffic, right? And therefore, our calls, our video calls, which are normally more important than other things, for example, someone browsing on Facebook or things like that, the voice would be privileged, real-time traffic or delay-sensitive traffic. Now, configure and verify Ipv4 addressing and subnetting. That's configure, all right? They will ask, how do you go to an interface? Actually, go to the interface level, and then just IP address, type in the IP address, specify the network address for each of the interfaces. That can also be set with Dhcp. So you need to know how to activate Dhcp, how to set up a Dhcp server. That's what I did. I actually did learn that. And I believe I got some questions about it. So that's very important. How to configure Dhcp server on a router, how to put a Dhcp pool, because you need to specify the starting range and the end range. You can also do an address reservation for the default gateway in order to avoid using or duplicating that IP address, because if you will set a default gateway manually and the rest will be set automatically, you need to make sure to use a proper range for the hosts. Then describe the need for private Ipv4 addressing. That's pretty basic too. The main reason why is even though we already have IP version 6, which has billions of IP addresses available, they say that approximately each grain of sand would have its own IP address if we used IPv6. So it's a great deal of IP addresses. Even though we have that, we're still using IPv4 because most of the devices in the internet are actually already configured in that way. And that has been defined by the IANA, which charges actually private companies, service providers, with some money for the address spaces that they give, public addresses. So that's what we're using, and that's why we need to conserve IPv4, because we have much less amount of a smaller amount of IPv4 addresses available. So we need to use network address translation, port address translation, where locally we can have these IP addresses pretty much in an unlimited amount. We can use class A, class B, class C, depending on our needs. Some enterprises have some servers and virtual machines, and they do actually need thousands and thousands of private IP addresses. And then those IP addresses actually identify locally those devices. And for public internet, we now can use just 1 or 2 or 3 IP addresses. It should be enough in order to be identified publicly on the internet. That helps us save a lot of address space. That's the reason why we have private IP addressing, to save IP addresses pretty much. Then configure and verify IPv6 addressing and prefix. It has a specific way to function, and it can be automatically set up to change the 7th bit, and that's just the way it works. It grabs the MAC address and it puts 4 Fs in the middle, and that way it can construct an IPv6 address for an interface automatically. So you need to know how that's done, and then if you have some zeros, they can also be shortened. There's a technique where you can put, for example, a colon, double colon if there's a bunch of zeros altogether, and that helps you have a shorter form of the IPv6 written form. You can also use a colon 0, for example. If it starts with 0, you can just omit the starting zeros in an octet. So there are certain rules that have to be memorized. And then configure. You need to know how to go to the interface and actually put IPv6, then put if it will be an automatic IPv6 address. You need to know also the concepts for you to be able to compare global unicast, unique local, link local address, FF80, anycast, multicast. Alright, that's where you send communications to multiple devices at a time. Anycast, just some devices. Modified EUI 64. Alright, you need to really know those concepts. There are tables too available on the internet, also from the official Cisco website. Those type of details are actually listed pretty clearly on the Cisco official website, and that's very useful to have. Alright, so far all of those are network fundamentals. Okay, verify IP parameters for client OS, Windows, Mac OS, Linux. So whenever you go to Windows, you go to, for example, Device Manager or Network Configuration Center, I believe. Network Configuration Center, and there you need to find the IPv4 driver, the network driver for the card, for the network card, NIC. And then just go to the option to IPv4, and there you can define if you will use a dynamic IP addressing or static. And if you're using static, you need to know that you can enter the IP address with a subnet mask with the default gateway information. And in Linux, you need to know bash as well as in Mac OS. There's a graphical interface too where you can enter the IP addressing information manually, like in a Windows environment, in a very similar way. The Dhcp can be set as well, and you can also use the CLI. Mac OS is also Unix based. It has bash, born again shell, like Linux does, and you can run Linux commands such as dir, ls to list units of a folder, the files, and then you can also use the commands to set up the IP parameters as well. So that's something to know. Verify parameters. So there you just need to know how they're checked. They can ask you, hey, how would you check? And in the question, it will give you multiple options. So you need to have that general idea so that whenever it's needed, you can select, oh yes, I remember, this is the option. Describe wireless principles. Non-overlapping Wi-Fi channels 1, 6, 11. Alright, etc. So on, so forth. The frequencies in general. 2.4 and 5 gigahertz. 2.4 is also used by other electronic devices such as phones, microwaves, so there could be interference. Also, the way the waves are shorter, they can traverse walls in an easier way, while 5 gigahertz has a longer wave which can travel longer distances, but it's a little bit more troublesome for it to go through walls or physical objects. And SSID, that's the identifier of the Wi-Fi network. Radio frequencies, there are some channels that can be used for, they're named scientific and research something channels. Encryption, WPA2, that's the encryption used, but you also need to know WEP, which is like Ethernet. It's supposed to be safe, but it's actually pretty, it's unused. Alright, you still need to know the encryption types for Wi-Fi. WPA2 is the one that we use nowadays. Now, explain virtualization fundamentals. Alright, Hyper-V, hardware-based virtual machines, multiple processing for virtual machines, and that becomes very useful when you start doing GNS3 labs, for example, because you can use the VirtualBox or VMware software, and you can set up the Linux containers, and inside of them you can actually put other internal virtual machines. So it's kind of nesting virtual machines inside of other virtual machines. So it's good to know how the resources of the computer, of the main hardware, are allocated to the virtual machines as well. In order to improve performance, what steps you need to do, all of that. Describe switching concepts. MAC learning and aging. You need to know how the switches learn the MAC addresses. There's a source and destination MAC address, the burned-in address, and there's an aging of 300 seconds by default. So you need to know that the switches learn based on the source address, source MAC address. Whenever a computer sends the frame, for example, the destination address could be all Fs. You also need to know that. You need to know how to convert from hexadecimal to decimal to binary sometimes in order to understand those concepts, how it actually works. So the all Fs address actually does a broadcast, and that sends the frame to all the devices that are there in the network in order to find the destination MAC address for a single communication based on the destination IP address. Alright, when the devices receive it, all the devices, or most of the devices in a broadcast, will drop the packet unless the IP address corresponds to them. And then the host will respond and will inform the initial ARP request device with an echo reply, ARP reply, and will tell the MAC address. And then the switch learns the other device MAC address too. So you need to know that. You need to know how that works, and if it's a default gateway, the computer is actually getting the router MAC address. And then when the router receives the frame, it will de-encapsulate the packet, check the destination IP address, and then back again form a frame and rewrite the destination address again. So you need to know that per hop behavior. Frame switching, frame flooding, MAC address table. How do you check on the device the MAC address table? Here it says describe, all right? But still, I would learn how the MAC address works. It has a CAM memory, content addressable memory, and that's what helps the switch basically store all the MAC address table inside it. Network access, configure and verify VLANs, virtual LANs. That's a technique that's used to subdivide the local area local area networks into smaller local area network subnets, based on the subnets too. So you need to know the IP addressing for subnet creation, and then also the VLAN creation in order to establish separated broadcast domains. So you need to know that virtual local area networks, and here it says configure. So you need to know how to go there, how to go to the config terminal section, and then just start creating the VLANs. VLAN 10, VLAN 20, VLAN 30, how to put a name to it. You need to know also that sometimes you can create a VLAN automatically. If you go to the interface level and you specify the VLAN access command, you can just put the name of the VLAN and it will automatically create it. And then you need to know that you have to exit the settings so that it actually applies. And whenever you do show VLAN brief, you will be able to see the VLAN actually created successfully and assigned to it. You can put a description, and it will show as the name of the VLAN too. Default VLAN, you need to know that there's a default VLAN, which is the VLAN 1. That one is there to stay. The other ones you can decide if they stay or they can be deleted. But the default VLAN is there, and that's where all the interfaces are assigned by default. So you need to know how to assign those access ports, as it says there, data and voice ports, and how to exactly go there to the interface level and assign the VLANs. Access VLAN 10 or 20, etc. Connectivity. You also need to know the ranges of the VLANs. By default, 1 to 1005. Some switches 4096. And then also configure and verify inter-switch connectivity. There's a way where you can interconnect multiple switches. For example, if there are multiple floors in the building, you can connect them with a twisted pair cable, and then you need to define the trunk ports. You need to actually set up the ports for them to allow certain VLANs that you want to allow the communication for. So then in order to do that, you need to go to that interface and you need to specify the type of trunking protocol and the mode that will be used. And there are two. There's the Cisco protocol for it to happen, ISL, but here, as it says, it specifically asks about 802.1q, which is a public standard, which has a smaller header, and makes the communication more efficient. So you can set it to auto, desirable, or just manually set the encapsulation. You can turn on the auto negotiation for the encapsulation too. You can specify the native VLAN there as well for it to be tagged, or for it to go untagged. By default it's untagged. You need to know why that's useful. For voice VLANs normally that's very useful, because you will have a phone which has the IP phones. Cisco IP phones have an internal switch too. They have an unmanaged switch so that it can understand VLANs. And then on the phone, maybe you have noticed, you can connect a computer. So you can connect a computer to the phone and the computer to the switch. So you have two devices connected on the same interface, and that's useful for native VLAN. Then configure and verify layer 2 discovery protocols. So Cisco Discovery Protocol and LLDP. You can put passive or active, or you can do desirable too, auto and desirable. And depending on what you use, so if it's active or passive, then you're using LLDP. If you're using auto and desirable, then you're using Cisco Discovery Protocol. Actually, devices normally can run both simultaneously. And what they do is they help you detect the details of the devices that are connecting on the interface. So for example, if you're wondering, all right, this interface is connecting a cable, and for some reason I want to know what device is connecting to that cable, you can just go to the CLI and show neighbors, show CDP neighbors, for example, or show LLDP neighbors, and it will give you the details. So they communicate using a protocol called CDP and LLDP, and that helps you to know from the CLI all of those relevant details. Most of the times you can find the MAC address, the type of device, the version it uses, the operating system it has, the management IP addresses, so you can try to connect to it. If you have Telnet or SSH access, you can configure from one device, jump to the other one. If there's a loopback interface, all of those useful details. Configure and verify layer 2 and layer 3 Ether channel. Ether channel is for redundancy and also aggregation. That helps you aggregate pretty much the multiple interfaces if they're connecting to the same device. For example, if you have two switches connecting with 8 or 16 interfaces, you can put all of those interfaces virtually together and you will get a virtual port. Whenever you show interfaces brief, IP interfaces brief, you'll actually see a new port listed right there, and that port is actually used as a single interface, even though physically there are multiple interfaces. So LACP, that's what helps us do, and that avoids the problem of the loops creation, because we also have another problem. That's why we have that other solution below that says describe the need for and basic operations of rapid PVST and spanning tree protocol and identify basic operations. So there, what it's saying there is, if there are loops, all right, we need to have redundant networks, and sometimes we connect the devices together. From a computer we connect a switch, and from the switch we connect another switch, and then if it's connecting to a third switch, and all of them are together connected, whenever a frame is sent and there's a broadcast, what happens is a broadcast storm, and that creates instability of the network, of the MAC address table, and the network could go down. That's why we have rapid PVST and PVST. First, you need to understand normally the traditional STP, so that with the traditional STP, you know how the tree is actually constructed. The tree is constructed based on a root bridge. You need to know how the BPDU's bridge protocol data units are formed. Each switch will have its own bridge ID, which is formed by the priority, which is 32768. It has that value by default, and then the MAC address table, the MAC address for that specific device. And we're talking about the MAC address of the device itself instead of just the interface MAC address, because each interface will have in a switch also their own MAC address. Based on the bridge ID, which will also contain the details about the cost. The cost, there are tables that you need to pretty much memorize, and they define the values for the cost of a segment. That's based on bandwidth, pretty much. The speed rate that can be transmitted on the line. That's the first factor that's considered in order to choose the root bridge for the spanning tree protocol. And you can also tweak the settings. You can also change the priority. You can do it in increments of 4096. That's something you need to know. You need to also know the handshake that has been added on rapid PVST, because previously there were timers on the traditional PVST. There were 15 seconds for the protocol to start, and then 20 seconds for a waiting period, listening, learning, and then forwarding statuses. So rapid PVST avoids doing that. It's much more efficient because it just sends a handshake, it takes probably 2 seconds as much for it to converge. And whenever you do the labs, you will be amazed with that functionality. Whenever you activate rapid PVST, wow, if you interconnect your switches, they will go green right away. You can see which ports are blocked, which ports are enabled. You need to also know the difference between the statuses, which is forwarding or blocked, and the other transitional descriptions, which is learning, forwarding, blocking, discarding, all of that. Then you need to know also, just have an understanding of MST, which is multiple. It creates actually multiple or one or two VLANs. Fewer VLANs can be used for multiple interfaces. That's useful whenever you have an environment with multiple VLANs all together. That helps you improve the performance. Otherwise, if you have thousands of VLANs, then you would need one root bridge for each VLAN. So it's harder for the processor to manage that type of information, that amount of information. Root port, root bridge, primary and secondary. You can set up a default secondary bridge. So if the first one, if the root bridge falls, it goes down, it has a problem, secondary root bridge can take over very quickly, and other port names. So yeah, you need to know the statuses, port states, port fast benefits. There is a functionality that can be set for end devices, because all of that handshake that allows the root bridge to be selected, and the backup root bridge, and the root port, and the alternate port, all of that works for switches itself. But there are other devices that can just go up right away. There you can set up port fast. And here, as it says, describe. That's the key. It says here describe. Whenever you're studying for the CCNP, it says troubleshoot and configure. So you do need to know specifically how to configure in a deeper way. So here it says describe. All right. So then that's what you will be focusing on, describing it, how it works. Then compare Cisco wireless architectures and access point modes. That's basically using the wireless LAN controller, or whenever they're standalone. You need to know how they're configured in general for wireless. Describe physical infrastructure connections of wide LAN components. Wireless LAN components. Yeah. Describe access point wireless LAN controllers, telnet, SSH, HTTP, HTTPS. So you need to know the ports. Telnet 21, SSH 22, HTTP 80, HTTPS 443, console 0, and TACAX radius. Console is for management. You can use a console cable to connect from a computer to one of the network devices and then manage and configure them. TACAX radius, that's for credentials. You can create a credentials server that will automatically assign username and passwords to users. Pretty useful. That can also be connected to Microsoft Exchange, which would help you create the username and passwords for multiple users on network based on the Windows policies, on the Microsoft Exchange profile. Configure the components of a wireless LAN using GUI. So you need to have an idea of QoS profiles, like I mentioned before. And then IP connectivity. Interpret the router. That's the 25% that we already read. And that goes pretty deep. Look at the verbs. Interpret, determine. Those are less heavy tasks. Apparently, right? But yeah, those are less heavier than configure, because configure goes a lot deeper into it. How would you configure a default route, network route, host route, floating static? You can set up a route with a different default administrative distance cost, so that whenever a protocol with a higher cost, for example, EIGRP, which has a cost of 90, OSPF that has a cost of 110, if they go down, then you have an alternate route. Floating static is what it does. You set up a value, specific administrative distance value, for example 100, when by default any static routes have a value of 1, and then it will take over first. Administrative distance, longest match. So by default the router will prefer the routes based on the longest match. Then secondly, it will consider the administrative distance, and thirdly, the routing protocol metric. Configure and verify single area OSPF. Single area, but it says configure, all right? Single area. In the CCNP already we have multiple areas. And then router ID, you can set it up. And otherwise, the loopback address will be looked. Otherwise, the local interface will be looked and chosen as the router ID. And there's a DR, designated router, backup designated router for broadcast. And describe the purpose. Just describe the purpose of the first hop redundancy protocol, HSRP, FSRP. There's a Cisco protocol for that. And what it does is it gives us redundancy for the wider network connection. We can have multiple routers connected, And then if one of them falls down, we have a virtual IP address set up as a default gateway instead of the physical IP address. And we will just use the other router. We can also do load balancing with it. IP services configure. Now this is 10%. This is 10%. I personally, I focused more on 25%, 20%, and the biggest ones, the biggest subjects, 20% here, network fundamentals. That's what I studied the most. And that was actually I believe the reason why I was able to pass on my first attempt. Because if I had studied deeper into IP services, there are some things that are very intricate, but they go very deep into the configurations. For example, configure and verify that IP services section is just 10%. I learned how to configure NAT using static pools, but there are some settings that are very, very deep. Alright, very, very deep. I just learned the basic configurations for all of these subjects. Of course, you can go deeper. You would ensure that you get that 10%. But what I did is I just studied that with flashcards. I just used flashcards, how to configure Ntp. I learned how it works. There's a basic clock. There's a root clock that's set for Ntp, Network Time Protocol. You can go on the CLI and just type in Ntp and define the local time. If it's Eastern Standard Time, Pacific Standard Time, Central Standard Time, Mountain Standard Time, put the time, and then all the rest of the clocks will be synchronized based on that one. So I just learned it. I just learned it for the test. Very rarely is actually used because the senior network engineers, they're the ones that normally set up the Ntp protocol. Explain the role of Dhcp and DNS within the network. Explain. DNS is to find domain name resolution. You can find the based, for example, on a website. Whenever you type in facebook.com, google.com, well, any website, the computer actually needs the IP address to be able to know where to send the packet. So DNS, that's what it does. It's actually a database, and it has the mapping of the names with the corresponding IP addresses. Explain the function of SNMP's Simple Network Management Protocol. That helps you gather logs, that helps you manage the network. It's very useful for troubleshooting. Describe the use of syslog features, including facilities and levels. You can set up a syslog server that will gather the logs from the device, because the device has a limited amount of memory. It can just store as much. And then you can have a special server where you gather and save your syslog messages. That way you will monitor the behavior in a better way. Then you can even have a monitor screen, a flat screen where everyone can see the status. You can set up diagrams, you can set up red flags, green flags, if everything's working well. And then you can compare. If you need to, you can go to the logs and you can see to the logs and you can check what differences are there in the network. What happened, if there was a problem, what was the difference, all of that. Configure and verify DHCP client and relay. Yes, you need to know how to configure DHCP, a DHCP client. Like we mentioned before, on the router, you can use the router as a DHCP client, or you can use the server as a DHCP client. Explain the forwarding per hop behavior of QoS, such as classification, marking, queuing, congestion, policing, shaping. What I mentioned before, that was important to know for quality of service, about prioritizing the voice over other types of traffic. For example, that's what we're talking about here. And there's a classification COS field which happens in the layer 2. The marking happens in the TOS. You can have a DSCP value for IP precedence and also for drop probability. And there, the telecommunications group created some standards called per hop behaviors. You can have an EF, which is the maximum priority, or an AF. They actually pre-chose because the markings can be up to 64 bits, but that can be too much. Cisco recommends to classify only with 11 classes. So the Telecommunications Association created that standard based on 12 markings. And then you can have four types of AFs and their corresponding 3 levels of dropping percentage. Then you can set up the queuing, which is shaping pretty much, and you can set up the congestion management, congestion prevention, to drop certain packets, normally the TCP packets, because they will be resent. The windowing will be restarted if the packet's dropped, and that helps you alleviate for a moment that policing packet dropping. With packet dropping, you can alleviate the network momentarily. Configure network devices for remote access using SSH. You need to know how to go to the interface and configure line console and line console 0, and then also specify the transport input telnet or transport input SSH. You need to know how to create a cryptographic domain-based key. To be able to use SSH, you need to set up a key, cryptographic key. Describe the capabilities and function of TFTP and FTP. That's the trivial file transfer protocol and file transfer protocol in the network. That helps you send files. That helps you send backup files. If you create, for example, a file which contains a list of information, you can transfer that information to a server so that it's stored over there where it has to be. There are actually some interesting scripts that can be activated sometimes on the routers, on the switches, because switches are actually, the Cisco iOS has the functionality of Linux commands. You can activate them and then you can run some scripts, which is something interesting to know. There are some tools that can help you schedule some tasks. There are some tools that can help you run some for loops. For example, you can use variables and then run some queries instead of just doing a show running config command. You can run a specific show running config command with some parameters for filtering the results of that command, and then save those results in some files. After that, you can send automatically to a TFTP server or FTP server that you have set up. So all of those things, yes, they're very useful to know, because whenever you go to the CCNP level, the percentages will be higher for those subjects. But here for the CCNA, I would focus more on the 25% and 20%. Security fundamentals, that's a pretty interesting and good one to know. You need to know the DOS attacks. You need to know how certificates protect your information and how encryption happens, how biometrics for authentication work. You need to know how to configure access control lists. So you need to go to the interfaces and know how to set up, based on the IP address normally, what devices, and also based on the ports and services, what devices are allowed to send and receive packets, pretty much like a firewall. And you need to know the encryption methods. You need to describe what multi-factor authentication is. You need to know what is the difference between the level of encryptions for passwords, because there's MD5, which is better than encryption 7, which was created by Cisco. You need to know how to enable password encryption, service encryption, and enable secret in order to improve the security of the device. And then at the end, you have what, to my personal liking, is the best and most interesting subject of the whole test: automation and programmability. Why to me is it? Because everything's interesting. Yes, everything is, especially all of these basic concepts that help you. If you master these basic concepts, I believe you can solve most of the problems on the network. And you can set up the networks. You can understand the next certifications, the CCNP certification. You can understand better all of the network devices. You can even work with Juniper devices. So it's pretty interesting. But here, why is it so interesting, automation and programmability? Because I studied Python. That's why my initial career was actually for advanced digital systems. And I actually automated on my previous job some processes that used to be done manually, very heavy processes that used to take several hours, and I reduced them to only be done in 1 hour or less, 45 minutes, thanks to programming, because I knew how to run scripts, how to construct scripts, and also how to do the interfaces. So full stack development, pretty much, the back end and the front end. Recently, I made an application for nutrition, so that it helps many people, including nutritionists, to calculate the metabolic rate, the kilocalories, the proteins, lipids, carbohydrates, micronutrients, all of that information based on the weight of the person, the age, and the height of the person. So it automatically calculates all of those details, and then you can connect the application to another database, which helps you find the amounts of nutrients that are in foods and their corresponding functions. It's a very interesting thing. Whenever you can solve real world problems with programming, it's amazing, because you can actually help a lot of people to solve important problems such as health, right? That's whenever I made that nutrition application, many people were very happy with it. I actually published the code in my GitHub account, which I have in my LinkedIn account published too. And that's what happens too in networking. There are many things that are heavy to do if you do them manually, setting up interfaces with IP address manually, setting up loopback interfaces, running backups, updating the device's operating systems. And sometimes we can even do small blunders, right? We're humans. For example, myself, I can type 306 words per minute. It's a pretty high rate, and very accurately I can do it. So, but still, we can do a little blunder, we can do a little mistake, and that can cause problems on the network. So it's better sometimes to have a script, because the script will do it perfectly. Most of the times, it will increase the efficiency and accuracy of our actions. Some task that may take several hours can be done simultaneously in multiple devices, saving us time, saving us efforts. So that's pretty useful. And also, now that we're starting to talk about software-defined networking, we're starting to see more and more Python programming, Python scripting, doing all of those trivial tasks automatically. We can even create, if we work with a team of developers, full stack developers, we can create specialized graphical interfaces for a certain company for them to manage it, because there are some softwares that help us do software-defined networking too, but sometimes they're very costly, and sometimes the companies prefer to have a team of engineers to build one for them. And that's just 10%, but very, very interesting. Very, very interesting subject. And you need to know how to interpret JSON encoded data. You need to know the formats. You need to know Puppet, Chef, which are Ansible automation possibilities too, that use markup language. You need to know overlay, underlay, which means basically an abstraction of the physical layer. Separation of control plane and data plane, northbound and southbound, APIs. That's to communicate your script with the rest of the network. So all of them are very interesting. I would really recommend you to focus in order to pass the test like I did on the strongest percentages, on the strongest subjects, and the rest maybe study them, practice them. If you do some labs and then some flashcards, especially for the configuration ones, that helps you know the commands in an easier way. That's what I did personally, and I passed on my very first attempt. So, well, thank you very much. I hope this helps, and we will hopefully go deeper into the subjects. I take advantage right now to recommend you some training, alright? I think probably you know them already because they're very well known in the networking industry already. So, people you can follow on the internet, they can provide you with some useful, deep training on each of these subjects. Some of them are CCIE, some of them are double CCIEs. Kevin Wallace, David Bumble, Keith Barker from CBT Nuggets, Network Chuck, Sean Hummel. Sean Hummel, he has an excellent training in Udemy. He has some practice tests too, which I took and I passed before doing my actual test. That helped me a lot, especially with the configuration commands. It's a very practical course. So, yeah, you can find more training online too. You can find some books. I really recommend you, of course, the Cisco Press Wendell Odom's book. I bought that one, and the investment was worth it, definitely. That's the best resource ever. After I saw the trainings, which gave me a general idea of how everything on the CCNA is laid out, I actually read the book, and that filled in the gaps. What I did is I practiced early in the morning, before the afternoon, and then the theoretical concepts, I learned them at night, because that way, to me personally, I digest the information better whenever I study the heavy theoretical concepts at night. I dream with it, and that helps me reinforce that. And whenever I'm recently waking up, I do the practices, I do the reviewing all the flashcards, because I'm more agile at that moment. Alright, well, thank you very much, and have a good day.